So here's the second example I wanted to do with you. And this one is also factored. Notice it's got a couple multiplicities of 2. So that means that there's going to be some bounces in our sketch. But again, this is about us making sure that we understand that when things get factored, how to sketch them correctly so that we can indicate the solution to the inequality in interval notation. So what I'd like to do is just go ahead and get started. This is going to be x equals 4. This is x equals 2, and that's a bounce. This is at x equals 3, and it's a bounce. So that's important for us to remember that when they're squared terms, that the graph is going to bounce itself. The next thing we have to do is our y-intercept. And I just got finished saying that when it's in factored form, the easiest way to do a y-intercept is to plug 0 in for x. Now, because there's square terms here, you got to be super careful. This is going to be, and I'm going to write this out so that I don't mess it up either. So 0 minus 4 is negative 4. 0 minus 2 is negative 2, and negative 2 squared is positive 4. And 0 minus 3 is negative 3, and negative 3 squared is positive 9. So what we have is negative 4 times 4, which is negative 16, and negative 16 times 9 is, I want to go negative 144. So our y-intercept will be 0, negative 144. The next thing we're going to do is we're just going to take a look at the shape of this thing. Now, we have 2 bounces in this thing, and we have a single root as well. Well, there's 2 plus 2 plus 1 more. That makes this a quintic. Now, we haven't seen quintics in a minute. So just to review, a quintic is a 5th degree polynomial. And all odd number degree polynomials share the same shape. So it's going to resemble a 3rd degree, except it might have more wiggles in the middle. And that just depends on, how ours is really set up. But anticipate starting bottom left, going to top right, having some wiggles in the middle, making sure that you go through 0, negative 144. So I'm going to get my sketch set up, and I'll be right back. Okay, so here it is. I've got my x-axis here, and I've got my y-axis here. I already put my negative 144 down there. And I did feel like I wanted to put the 1 in just so that it looked a little bit more uniform. Now we're looking at this inequality. That inequality says that I need less than 0. Less than 0 indicates that we want all y values to be below 0. So that looks like a dip in the graph under the x-axis. That's what this means. It also means that you're going to have an open circle for all zeros. So where we have 4, 2, and 3, we need to have open circles because there's no equal to sign. So 4 is open, 2 is open, and 3 is open. Now this is going to be tight. The other thing we need to remember is that there is going to be some wiggling going on in here because it's a quintic. It's got to start bottom left. It's got to cross through that negative 144 before it hits. So it's looking like down here, we're going to go through negative 144. We're going to come up through, we're going to bounce at 2. So come back, bounce, come back, bounce. We're bouncing at 2. We're bouncing at 3. And then finally come back and go through at 4. So all of the wiggles that are happening are bouncing at that 2 and at that 3. Just like this. Now, I'm not sure if this dips low and back up or what. I just made it bounce. So it looks a little bit squiggly like a quintic is supposed to, obviously, but these values are tight. So now what we have to do is figure out our shading. Now, we need it to be less than 0, which means the y values have to be under the x-axis. So essentially, all the places where it's under the x-axis are most of it, except for here. And our open circles. Remember, open circles means that it's not included. So we have from 2 to 3 is underneath. We have from 3 to 4, which is underneath. And we have from negative infinity all the way to 2, because that's all underneath. So all of this is going to be shaded. What complicates matters here is the open circles. That means it's not continuous. That means that you literally have 1, 2, 3 sections that you need to talk about with your union. So the first section goes from negative infinity to 2. So we would have a parenthesis, negative infinity to 2. It's a parenthesis because it's an open circle, because there's no equal to. Our next section is from 2 to 3. Again, parentheses, because 2 and 3 are not included. And then our next section is from 3 to 4. So I need another union. And that's my entire answer. My solution set for this inequality is negative infinity to 2, union 2 to 3, union 3 to 4. Those are all of the sections of x where y dips under the x-axis. And again, the reason why we have 3 sections, we have to, is because they're open circles.